Back, and so now we want to discuss why does magma form in the first place. So why do we have this distinction between liquid material, the magma, and then the solid material, the rock? Okay, there's basically going to be four things that are going to control whether or not you're going to have a liquid or a solid. So the first one is going to be temperature. And in this diagram here, temperature is going from right to left. And so you have the lowest temperatures are on the left, the highest temperatures are on the right. And you should notice a trend. So as you increase the temperature, it becomes more likely that it's going to change from solid rock to a magma. Okay, you'll also notice that there is a blue line, and the blue line is going to be the real temperature gradient inside the Earth. So the red line is going to be the theoretical temperature at which this solid rock is going to melt and turn into a liquid. So that's what the red one is. Now the blue one, on the other hand, is telling you what is the actual temperature the deeper you go inside the Earth. And now this temperature is going to be affected by pressure, so that you notice that it's not just a nice straight line. The deeper you go, the temperature does go up. So you notice the deeper you go inside the Earth that the temperature is increasing, but it doesn't increase at a uniform rate. And then notice that the two lines cross each other there in the middle. So at first, so let's start at the surface of the Earth. So at 0 kilometers inside the Earth, notice that the temperature is basically 0 degrees Celsius, room temperature. Okay, notice that you would not have any magma at that temperature. All right, now we're going to start to go deeper inside the Earth. So let's say we go down to 50 kilometers inside the Earth. Now you'll notice that the temperature is up to around 800, but that's still not enough to melt the rocks. So we are still inside the crust of the Earth at this point, or we're still inside the lithosphere. Okay, but notice that when we get to around 100 kilometers inside the Earth, that the blue line, which is the actual temperature of the Earth, crosses that red line, which is going to be the temperature required to actually melt the rock. And then you notice that it actually comes back out when it gets down to around 200 kilometers. So that place right there between 100 and 200 kilometers, that corresponds to the asthenosphere of the Earth. So it's a place where the pressure is not enough to compress the material and make it turn solid. And so temperature is winning in the asthenosphere, and the rock melts in that part of the Earth. And so that's going to be the origin of the magma that is eventually going to come to the surface and then come out of volcanoes. So you'll see also up there at the top that igneous rocks tend to form in temperatures between 600 and 1200 degrees Celsius. All right, let's take a break, and when we come back, we'll talk about how does pressure affect the formation of magma.